Relating graphs to events. Graphs are used to show the relationship between two variables. The skills that we need when we're working with graphs are interpreting graphs. We need to be able to figure out what they're trying to tell us. We need to be able to sketch graphs, and we need to be able to analyze graphs and dig deeper into the information that's being conveyed through them. Interpreting graphs. A student walks and takes a bus to get from school to home each day. Describe what the graph shows by labeling each part. So here we have the student's graph of their commute home. The two variables that we are comparing with this graph are total distance and time. And the graph, as you can see, starts off with a pretty steady increase in distance and time. Then we have this horizontal section where time continues to pass by, but there's no change in the total distance traveled. Then we have this sharp increase here where a fair amount of distance is traveled over a short amount of time. And then we come back to kind of where we started with this steady increase in distance and time. So we can assume that this steady increase in distance and time is when the student is walking to the bus and to home. This sharp increase in distance traveled must be happening while the student is taking the bus. We know that because it's traveling a greater distance over a shorter amount of time compared to the sections when the student is walking. And then this flat section here where our graph plateaus, where time continues to pass by but no distance is traveled, must be when the student is waiting for the bus. Sketching a graph. A plane is flying from New York to London. Sketch a graph of the plane's altitude during the flight and label each section. So if we were to sketch a graph, obviously we're doing a rough sketch. We're not using coordinates or ordered pairs just yet, but just trying to sketch a graph, draw a little bit of a picture to get a visual of what the flight would look like for this plane's trip from New York to London. So what we would see is, here we are comparing the altitude and the time. So what we would see as this plane flies from New York to London is we would probably start off with a sharp increase in altitude as the plane takes off. And then we would see it plateau out for most of the duration of the trip. And this is probably when the plane is kind of cruising altitude. So once the plane starts to get ready to land in London, we're probably going to see a drop off in altitude. Then maybe it hits a spot where it's circling the airwaves and making sure it's waiting for the signal that it's good to go and it can land in London. And then when it's ready to land, we will see another sharp decrease in altitude as well as it lands in London. So labeling each section, here we would have our departure or our takeoff. Here is our cruising altitude, and that takes up a great amount of the time of the trip. This section we have preparing to land or preparing to descend. Maybe you want to put in here about circling the airways. And then this section here would be when we are landing or arriving in London. Analyzing graphs. A car travels at a steady speed. Which graph could you use to show the speed of the car, and which could you use to show the distance? Explain. So we've got two graphs here, one to show the distance and one to show the speed, but how do we figure out which one is which? On both graphs you can see that time is one of the variables that we are comparing the other variable too. So our other variables being speed and distance. We have to figure out which one can convey speed over time and which one can convey distance over time. So if we take some clues from the story that's being told, we know that the car is traveling at a steady speed. It's not going fast and then slowing down. It's pretty steady all the way through and pretty consistent. So as time passes, here we can see this variable, whatever this may be, is not changing. It's staying the same because it's the same amount up that number line. So it's staying the same. We know that the speed is steady, which means it's staying the same. So this variable must be speed. And over here we have time, and this variable here is increasing just as time increases. So there's a steady increase in whatever this variable is as time goes by. So even if the car is traveling at a steady speed and not accelerating or decelerating, it's still increasing the distance as it continues to travel at that steady speed. So this variable must be the distance.